This is Mr. Beck Does Your Homework, AP Physics, Homework 7.2, questions 5 and 6. Engineers have developed a bathyscaphe, I think that should say, that can reach ocean depths of 7.3 miles. This is just a one type of a ocean submarine sort of thing. So 7.3 miles. If the density of seawater is about 1030 kilograms per meter cubed, what is the absolute pressure at that depth? The absolute pressure is going to be the pressure due to the water plus the pressure due to the air. The acceleration of gravity is. So at that very deep depth, I'm going to have an H. So that's going to give me some rho GH of pressure, but I've also got atmospheric pressure, and that's just one atmosphere since they didn't tell me any different, which is 101,300 pascals. So rho GH, that is going to be the density of 1030 times G, which is 9.8, times my H, which is, let's see, 7.3 miles. Each mile is 1609,344 meters. So that's going to be 7.3 times 1609.344. That's my rho, my G, and my H. So when I take this plus this, that will give me my absolute pressure. Is going to give me my 101,300 plus my rho GH. That will give me my pressure at that depth. The next question says, if the inside of the vessel is maintained at atmospheric pressure, what is the net force on a porthole of diameter 15.2 centimeters? So now I've got this little porthole in the submarine, and on the inside I've got 1 atmosphere. On the outside I've got this whole thing here. But wait, there's my 1 atmosphere. So on the outside, don't I just have rho GH here plus an atmosphere? But the net force is going to be the inside and the outside and the difference. But I've got an atmosphere on the inside and an atmosphere on the outside. So it's really rho GH is the difference between the pressure. So that's going to be the net pressure is going to be this whole rho GH. Now I've got to find the force on the net force on the porthole. So all I'm caring about is that net pressure because the atmosphere itself cancels out. So now my force is going to be my pressure times my area. Well, 15.2 centimeter diameter, to get an area from that, I've got 15.2 centimeter diameter. Well, that centimeters is 0.152 meters is my diameter. So my radius is going to be 0.152 divided by 2. Take that and do pi r squared. So take this, square it, times pi. There's my area of the porthole is pi r squared. So my force, net force, is going to be the pressure, which is this net pressure, because I already dealt with the atmosphere, times that area.